This is a tutorial on C++ classes and inheritance. My name is Noel Oates. The C++ programming language allows us to use one or more data types and group them as a single data type to create a new programmer-defined data type. One way to do this is to create a class. Classes are the feature of C++ that supports object-oriented programming. A class has members. These class members are member variables and member functions. The member variables and member functions of a class describe the properties and behaviors of objects that will be created from that class. Classes are also referred to as composite data types, since the class is a grouping of member variables of different data types and member functions having return values of different data types. One of the most important concepts in object-oriented programming is that of inheritance. Inheritance allows us to define a new class in terms of an existing class. It is often said that with inheritance, we are extending an existing class within the definition of a new class. Why is this important? Instead of writing completely new data members and new member functions in a new class, the programmer can simply implement inheritance so that the new class inherits members of an existing class. In this example, we will implement inheritance between a parent class and some child classes. That is, the member functions and member variables of the parent class will be inherited by the child classes. To summarize what we will review in this first Xcode project named Coding the Tutorial, we will create the initial file that will contain 3 class definitions and the main program. We do not yet implement inheritance in this first project. In declaring and defining the 3 classes, we will review the following aspects of C++ classes: the class structure, class member variables, class member functions, the class constructor function, the public interface to the class, coding conventions, class member access specifiers, data hiding, and preprocessor directives, which in our case we need for using C++ standard library classes and objects. We test object creation of each of our new classes. We also test that the objects can invoke class member functions. By having the new objects invoke class member functions, we can output information about the new objects to the monitor. Let's take a quick look at the code. To save time and to make this example easier to understand, I've created all of the class definitions and the main program in the same file. In our example, we will first write the class definitions for 3 different 2-dimensional geometric shapes. We will define a circle class so that we can create and use different circle objects. These objects are said to be of the type circle. We define a triangle class so that we can create and use different triangle objects. These objects are said to be of the type triangle. And we will define a rectangle class so that we can create and use different rectangle objects. These objects are said to be of the type rectangle. To quickly show you how the file is structured, here's the code for the circle class. Here's the code for the rectangle class. Here's the code for the triangle class. And here's the code for the main program. Before reviewing the code further, let's do a quick unit test to prove that our classes can successfully create objects. Okay, so we can quickly see from the output that we have created 2 circle objects with IDs of circle 1 and circle 2, a rectangle object with ID of rectangle 1, and a triangle object with ID of triangle 1. So we see that these 3 class definitions can now be successfully used to create objects. So let's look a little closer at the code. Let's take a look at the circle class. We declare a new class using the class keyword and then the name of the class, which always has to start with a capital letter. We will now open a set of curly braces and declare the member variables and define the member functions of the circle class. We see that the next line of code is the word private with a colon. This is actually known as a class member access specifier. So before we actually move forward in our code review, let's first review C++ class member access specifiers. There are three types of member access for a class's member variables and member functions. They are private access, public access, and protected access. Protected access pertains specifically to inheritance, and we will defer discussion of protected access until later. For now, we will discuss the private and public access specifiers. Class access specifiers give the programmer of the class the ability to decide which class members are accessible to users of the class and which members are for internal use only within the class. The class members that are for internal use only will be given private access. This allows the programmer to have their own private class data that is inaccessible to all other users of the class. This provision of C++ is known as data hiding and protects the programmer's data from accidentally being overwritten by other users of the class. If the programmer who authored the class declaration does not specify the access control for some class members, by default, C++ will specify that these members have private access to ensure data integrity. Class members that are to be accessible to other users of the class will be given public access. These members are said to be the public interface to the class. And one special member function of the class that must be publicly accessible is the class constructor function, which we will discuss in detail later. In the class definition for the circle class, we declare two member variables. Notice that the circle member variable names have an m underscore prefix to a descriptive variable name, in this case m underscore user ID. There's good reason to name a class member variable using the m underscore prefix. By convention, it is good practice to give easily identifiable names to class member variables. And GNU coding standard uses the m underscore as a prefix to a descriptive name for class member variables. By using this convention, your code will be easier to read. The m underscore prefix immediately identifies this as class member data. We will see how this convention for naming member variables will help avoid confusion. Now let's consider the member functions of a class. The first member function to consider is the class's constructor function. When an object of a class is created, the class constructor function is invoked. Now, a class constructor function is a special member function of a class that is executed whenever we create new objects of that class. The class constructor function is the public interface to the class and must have public access so that other programmers using the class can see what is accessible to them. The class constructor function will have a function name that is the exact same name as the class. Now note that a class constructor function does not have any return type at all, not even void. We see that the circle class constructor function has two arguments. The first argument is for accepting the value of a string variable. We will call this function argument user ID. The second argument is for accepting the value of a float variable. We will call this argument radius. These argument names are intentionally derived from the descriptive part of our member variable names. In using this convention where constructor argument names are the same as the descriptive part of our member variable names, we will avoid confusion when we assign the values passed into the function arguments to our member variables. The creation of a new object of the class invokes the class constructor function, and this initializes our member variables, assigning them the values provided in the object declaration. Note that what looks like an equals sign is actually the C++ assignment operator. It is not an equals sign. C++ assignment level expressions are evaluated from right to left. So the correct reading of the syntax is the value passed into the user ID argument is assigned to the new object's member variable m underscore user ID, and the value passed into the radius argument is assigned to the new object's member variable m underscore radius. The actual values that will be passed into the user ID and radius arguments of the circle class constructor function come from the declarations of new objects of the circle class. Object declarations can occur in the main program, in another class of the same implementation, or in other programmers' implementations. We also will presume that other programmers using the class in their implementations may need to change or query values of a member variable after they've instantiated an object of the class. For this reason, we will create setter and getter member functions and make them part of the public interface of the class. Another name for setter functions is mutator functions, and another name for getter functions is accessor functions. Let's take a look at the setter function for the member variable m_user_ID. This setter function will give the programmer the capability to change the value of this member variable. The setter function has a single argument to accept the new value for m_user_ID. This value is a string of characters. We remain consistent in using the function argument name of user_ID for functions affecting the member variable m_user_ID. Setter functions set new values for member variables. They do not return anything, so their return type is void. To change the value of m_user_ID, the object invokes this setter function and passes the new value to the function's user_ID argument. This new value is then assigned to member variable m_user_ID. Here's the getter function for the member variable m_user_ID. Since the getter function gets the value of the member variable from memory, the type for this return value must be specified, which, as we know, is a string of characters. Also, getter functions do not change anything, so those functions are declared const. Note that the class member function names use a camel case convention and are deliberately named so to provide an intuitive function name that identifies what this function will do and what variable it will do it to. The words set and get are typically used as part of the member function name. Let's now look at the rectangle class and compare it with the circle class and the triangle class. The structure of all three of our classes is essentially the same. Each of our classes is a blueprint for a two-dimensional geometric shape. Each of our class definitions begins with the declaration of the class's member variables. In all of our classes, the member variables are given private access control. We have created the member variables for each class for two specific purposes. The first is to be able to assign a unique user ID to each object created from these three classes. And the second is to be able to identify the dimension attributes of the two-dimensional shape. Our classes basically differ from one another only in the unique member variables necessary to describe the dimensions of the two-dimensional shape. While circles will necessarily have a radius variable, rectangles necessarily have length and width variables, and triangles have base and height variables. Following the declaration of the class's member variables, we create the public interface to the class, giving this section public access control. The first part of the public interface of the class is the class constructor function. When a new object of the class is declared, the class constructor function is invoked and the object's member variables are initialized with their first values. Also, within the public interface of each class, we have created getter and setter functions for each of the member variables so that users of the class are able to get or retrieve the values of member variables and also are able to change or set new values for the member variables. In our program, we will also use some classes that were written by other programmers. We will use a couple of classes provided in the C++ standard library because these classes can generate certain objects we will need for our program. We will access these C++ standard library classes by using preprocessor directives. In our case, we will use the include preprocessor directive, where the word include is preceded by hash mark. This preprocessor directive tells the processor to load the code of these standard library classes and to include that code with our code before compiling. We tell the processor to load two C++ standard library classes. We tell the processor to load the IOStream class and the string class. The IOStream class can generate input and output stream objects, and our program needs to use the IOStream class so that we can create the cout object. We can then insert characters into the cout object and output them to the monitor. The string class creates objects that represent sequences of characters, and our program needs to use the string class to support our use of string variables. Looking closer at the main program, we first declare an object of the circle class. We name this object first circle object, and we provide values for the two arguments of the circle class constructor function. We provide a value of circle1 for the user ID argument and a value of 14.14 for the radius argument. When the circle class constructor function executes, these values will then be assigned to first circle object's member variables, m_user_ID and m_radius. We next declare another object of the circle class, which we name second circle object. And for this object, we provide values for the two arguments of the circle class constructor function. We provide a value of circle2 for the user ID argument and a value of 20.082 for the radius argument. When the circle class constructor function executes, these values will be assigned to second circle object's member variables, m_user_ID and m_radius. To confirm successful invoking of the circle class constructor function by these two new circle objects, we have both of them invoke getter member functions to get the values of our member variables, which were just assigned by the circle class constructor function. And then we output these values to the monitor using the cout object. Note that to invoke class member functions like our getter and setter functions, the objects use the .member selection operator, a period mark, between the object name and the member function. Let's run the code. Okay, let's quickly compare this output to the lines of code above to see how we insert information into the cout object for output to the monitor. On separate lines, we print the values of the member variables of these new circle objects. We print the values of m_user_ID and m_radius for both objects. Next, we test successful invoking of our circle class setter member functions. First circle object will invoke setter function setUserID to change the value of member variable m_userID from circle1 to a new value of circle 500. First circle object will then invoke another setter function setRadius to change the value of m_radius from 14.14 to a new value of 18.6. We confirm this by output to the monitor. Second circle object also invokes these circle class setter member functions to change values for its member variables m_userID and m_radius. We use our getter member functions to get these new values for the member variables of these circle objects, and we insert this information into the cout object for output to the monitor. Let's run the code. To summarize what the main program does right now, we have created two new circle objects, initializing each of their attribute values and confirming this by output to the monitor. We then changed attribute values of these new objects, confirming this change by output to the monitor. We follow this same basic approach to confirm the functionality of the rectangle class and the triangle class. Now that we have some understanding of C++ classes and objects, and the class constructor function, and some other class member functions, namely the setter and getter functions for each member variable, we can look at the entire code and see that it is really a very simple program. Our review of the code is made easier by the layout of the code, which is based on GNU coding standards, where each statement is on a separate line. Also, the curly braces, which open and close the classes and the member functions of a class, are on their separate lines as well. We see the beginning of the program is where we have the preprocessor directives. We are directing the processor to preload the two C++ standard library classes, the IOStream class and the string class. Remember, we need the standard library string class because we want to use its objects to handle our string variables. For example, m_userID. And we need the IOStream class because we want to use its cout object and insert information into cout that will then be output to the monitor. We necessarily put the preprocessor directives at the beginning of our program. This tells the processor to load those standard library classes now, prior to loading our code, combining the code blocks in this order before compiling. Moving down into the code, we first look at the definition of the circle class. We see that member variables of the class have private access. We understand that this allows the author of the class to hide their private data from all other users of their class. We next see the circle class constructor function. We understand that the constructor function is the beginning of the public interface to the class, and that the public interface to the class allows other programmers to use our class. This is why the class constructor function is given public access. We see that the constructor function specifically identifies two function arguments, and we understand that the objects created from the circle class must provide the values for the two constructor function arguments. We understand that the execution of the circle class constructor function happens only at the time when a new object of the class is being created, and that this results in the circle class member variables receiving their initial values. We understand that after the constructor function has initialized the class member variables with their first values, these values can be retrieved from memory by using a getter member function that we wrote for these variables. We also understand that these member variable values can be changed later using the setter member functions we wrote for these variables. We understand that objects created from a class can invoke the class's member functions using the .member selection operator. At this point, we have learned the basic requirements for creating C++ classes and objects. And we have written the code we need to move forward with our next discussion of C++ class hierarchies and inheritance. In the next session, we will learn how inheritance provides significant efficiencies in object-oriented programming.